We've looked at several of our formulas for finding the sum and difference, the sign for the sum and difference of two angles, or the cosine or the tangent. So we have our sum and difference identities or formulas. We have our double angle formulas. And in this lesson, we're going to look at our half angle formulas. And I'm not going to take the time to show you how these formulas are derived, but we will go through them. We've got that the sine of half of an angle is equal to plus or minus the square root of 1 minus the cosine of an angle divided by 2. Now, we'll go through and figure out how to know when you put the plus or the minus, and whatever angle is here in your numerator is the angle that we're going to use here. The cosine of half of an angle is equal to plus or minus the square root of 1 plus the cosine of the angle over 2. Then for the tangent of half of an angle, that's equal to plus or minus, well, it's sine over cosine, and since the denominators are the same, they would cancel, so it's going to be the square root of 1 minus the cosine of A over 1 plus the cosine of A. Now we're going to be able to do some things with our tangent formula that would make it just a little bit easier. And we're going to go down and let me just show you some things that we can do. Okay, let's go back. We've got that the tangent of half of an angle is equal to plus or minus the square root of 1 minus cosine A over 1 plus sine A, cosine A. Now, if we decided that we would multiply this by the denominator, 1 plus cosine A, we're wanting to get rid of the radical. So we're going to multiply this by the square root of 1 plus cosine A. Now, if this were a positive, then a positive times a positive would be a positive, a negative times a negative would be a positive. So it's going to work that when we multiply this, that our signs are going to be taken care of. And so we're not going to have to worry then about this plus or minus out here. But what we get is the square root of 1 minus cosine squared A over sine, 1 plus cosine A squared. These were conjugates in the numerator, so we had the 1 minus cosine squared A over 1 plus cosine A squared. Now 1 minus cosine squared is sine squared. And when we take the square root of this, that's actually when we'll get rid of our plus or minus. We always take the principal root, and so we end up with the sine of A over 1 plus cosine A. Now we could go back and we could do the same thing where we multiply both of them by the minus. So what we're going to end up with in the numerator, we would have 1 minus cosine A squared over 1 minus cosine squared A, because now it's the denominators that are conjugates. And so when we take the square root of this, we're going to have 1 minus cosine A over, and that's sine squared, so the square root would be the sine of A. So this gives us two variations for our tangent formula where we don't have to deal with the radical. It can also then be sine A over 1 plus cosine A, or it can be 1 minus cosine A. Let me make that one a little different, just so we can see them easier. 1 minus cosine A over sine A. So with the tangent, we're going to have a choice, and we won't have to deal with the radical. With the sine and the cosine, we're going to have to deal with the radicals there. So let's look and see how we can go about using this to find some values. Let's say that we were told that the sine of A was equal to negative 3/5, and that A was between 270 and 360, which means A is in the fourth quadrant, but it's going to be a little bit easier for us to write it in this form than to say it's in the fourth quadrant. Okay, what we want to find is the cosine of half of A. We have some angle that we know the sine for it. We don't necessarily know the angle, and now we want the cosine of half of that angle. Well, our formula for the cosine was plus or minus, and if we go back and look, it's the 1 plus cosine A over 2. Okay, now, first of all, let's take care of this plus or minus outside. The way that we take care of this is we look up here. We're trying to find the cosine of half of A. A is somewhere between 270 and 360. So half of A would be between half of 270, which is 135, and half of 360, which is 180. So if A is between 270 and 360, half of A is between 135 and 180, which is quadrant 2. Now in quadrant 2, the cosine is negative. So we can take care of that right away, and once we decide which sign this is, we'll carry this sign throughout the problem. Now, inside the problem, we're talking about the cosine of A. So we have to go back then, and we need the cosine of A. Well, we don't know that, but we can draw our triangle. We know that the sine of A is 3/5. So this is a 3, 4, 5 triangle, and A was in quadrant 4. So when we want the cosine of A, it's going to be 4/5. We're in quadrant 4, so the cosine is positive. You're dealing with basically two different angles. You're dealing with half the angle, which tells you about the sine out here, and you're dealing with the function of the angle, which it will probably be in a different quadrant. So be sure that you take care of those in two different ways. Now the rest of this is arithmetic. We've got to get a common denominator, which would be 5/5 plus 4/5 divided by 2. So that's going to be 9/5. And I'm going to go ahead and say divided by 2 is the same as multiplying by 1/2. So we have the square root of 9/10. Well, we know the square root of 9. That's 3 over the square root of 10. And then we'll rationalize by multiplying both the numerator and denominator by the square root of 10. And we get negative 3 square roots of 10 over 10. And that's what the sine of half of that angle would be. Now let's say that we wanted to find the tangent of that same angle. So on the tangent, if you remembered, we had 3 different formulas that we could use. And probably the one without the one of the ones without the radical would be easier. And I'm going to use the 1 minus cosine A over sine A. So the tangent, let's do this just so we'll recognize it's a different problem. The tangent of half of A is equal to 1 minus cosine A over sine A, which would be 1 minus, now the cosine of A was 4/5, and it's a positive number. The sine of A was negative 3/5. And so now we'll do our arithmetic. We've got 1, which would be 5/5, minus 4/5 would be 1/5, divided by negative 3/5. Well, our denominators here are the same, so those cancel, and we get negative 1/3. And we didn't have to deal with that plus or minus outside the radical because it was taken care of when we rationalized and came up with those new formulas. So this is how we can go through, and given a value, then we can come up with half of that angle, a function for half the angle. And we could have done the same thing. We could have found secant, which would simply be the reciprocal. We could have found cotangent, which would have been a negative 3. The reciprocal, we could have found the sine of half the angle. Okay, let's look at another one. Let's say that we were told that the sine of beta was negative 2 square roots of 2 over 3, and that beta was in quadrant 3. So beta was between 180 and 270. Okay, for this, we're going to find the sine of half of beta, the tangent of half of beta, and the secant of half of beta. So we're going to do several problems. Say we want the sine of beta over 2. Well, that's equal to plus or minus the square root of 1 minus the cosine A, or beta, b over 2. And I always start with writing my formula. Okay, now I want to take care of the sign outside. We can do that right away. So if b is between 180 and 270, then half of it's between half of 180 and half of 270, which is quadrant 2. B is in quadrant 3, half of B is in quadrant 2, so the sign's going to be positive. And that will be 1 minus, now the cosine, to find that I need to draw my triangle. If this is B, the sine was 2 square roots of 2 over 3, and that was in quadrant 3. Now to find my other side, I'm going to need to do my Pythagorean theorem. So that's going to end up, since I know the hypotenuse, it's the hypotenuse squared. So 3 squared minus the side squared will equal my other side squared. So that's going to be 9 minus, this would be 4 times 2, which is 8. And so my other side squared is 1, and then we would take the square root of that, and it will be 1. And we're in quadrant 3, so it would be a negative 1 if you wanted to go ahead and put your signs there. So the cosine is going to be 1/3. Quadrant 3, it's going to be a negative 1/3 over 2. So this is going to be 1, which would be 3/3 plus a negative times a negative. So 3/3 plus 1/3 would be 4/3. Divided by 2 is the same as times 1/2. So those will cancel. We end up with the square root of 2/3, which we can then rationalize by multiplying by the square root of 3 over 3, and we get the square root of 6 over 3. Okay, if we wanted the tangent of beta, now we have a choice. Again, I would not use the radical one. I like to use the one with the sign in the denominator so that I don't have a sum or difference. So I often will use this one. That way I just have one digit in the denominator. I don't have a sum or difference, which I'm not going to have usually. If I have a radical, I would have to then deal with the conjugate. So this is going to be 1 minus, okay, the cosine was negative 1/3 over the sine would be negative 2 square roots of 2 over 3. So let me get a common denominator up here, which is going to be 3. So this would be 3/3 plus 1/3. So that's going to be 4/3 over negative 2 square roots of 2 over 3. My 3's will cancel. My 2 will go into 4 2 times, so I end up with negative 2 over the square root of 2. And I can rationalize that multiplying by the square root of 2. I get 2 square roots of 2 over 2, and those will cancel, so I have negative the square root of 2. I had needed to bring my negative sign down there. So that would be the tangent. Okay, let's say we want to find the secant of beta over 2. Well, the secant's the reciprocal of the cosine. So this would be plus or minus the square root of 2 over 1 plus cosine of b, which would be plus or minus the square root. Oh, the plus or minus. Let's see, which one would that be? Half of beta is in quadrant 2. Secant's the reciprocal of cosine, and in quadrant 2, cosine is negative. So it's then going to be the negative. Then we would have 2 over 1 plus, okay, the cosine was negative 1/3. So that gives us negative the square root of 2 over. This would be 3/3 minus 1/3 would be 2/3, which will be negative 2 over 1 times the reciprocal, 3 over 2, or negative the square root of 3. So given one function, you should be able to find all 6 of your trig functions for half your angle. And that's one use we have for our half angle formulas. We also want to be able to find some angles for them. And let's start out. Let's find the sine of 15 degrees. Now we did this with our difference formulas. We said 45 minus 30, and that's a good way of doing it. We want to do these with our half angle formulas, and what you're going to find is our answer will look different, but it works out to be the same value. And so you want to make sure that you do these by the half angle formula. Now to know what angle this is, multiply it by 2. And so the sine of 15 degrees is equal to the sine of 30 over 2, which will equal plus or minus the square root of 1 minus the cosine of 30 over 2, putting it into our formula. So remember, whatever angle this is the angle we use here. Now to figure out our sine here, it's a little bit easier than it was with our just knowing a function, because we actually know the angle. We're trying to find the sine of 15 degrees. 15 degrees is in the first quadrant. In the first quadrant, sine is positive. So we're going to use the positive. So we have 1 minus. Now, the cosine of 30 is square root of 3 over 2, all over 2. And the rest is just doing our simplifying. We'll get us a common denominator up here in our numerator, which would be 2. 1 would be 2 halves. So we would have 2 minus the square root of 3 over 2. Then divided by 2 is the same as times 1 half. We took this divided by 2 and we changed it to times 1 half. That's since we already had a fraction. So we end up with 2 minus the square root of 3 over 4, and we know the square root of 4. So our final answer would be 2 minus the square root of 3 over 2. Now notice this 2 is not under the radical because that was the square root of 4. We took the square root of 4 and it gave us 2. And we came up with that value. Now, if you were wanting to check these, basically what you would do is you would go to your calculator and you would see what the square root of, the square root of 2 minus the square root, the square root of 3. Okay, we're closing it for the square root of 3, then we're closing it for what was under the radical, divided by 2. And we get 0.25. Now, I had already checked to make sure my calculator was in the degree mode, but you would want to check that. And then if we said, okay, now what is the sine of 15 degrees? We get the same answer. So it did turn out. If we had done these using our sum or difference identities, our answer would have been different. And we would have needed to, you need to make sure that you learn how to do your half angle. And if we had done that the sine of 45 minus 30. Well, if you remember, that was the sine of the first, cosine of the second, plus cosine of the first, sine of the second. That was the square root of 2 over 2, square root of 3 over 2, plus the square root of 2 over 2 times 1 half. And so we ended up with the square root of 6 plus the square root of 2 over 2. So you can see those don't look the same at all, but they do give you the same value. If we went back to our calculator again, and we did, okay, the numerator, and then had the square root of 6 plus the square root of 2, close the numerator, divided by 2. Whoops. Okay, I didn't do something right. So let me just go through and check this. Okay, I put divided by 2. Let me go back. It's supposed to be divided by 4 over here, because 2 times 2 is 4. And so let's just back that up. Press enter, and we still don't have the same answer, so I still have some mistake. Okay, I know that y'all are sitting there yelling at me saying in the formula for the sine it was a minus, and this is supposed to be a minus because it was 45 minus 30. I was working quickly and making lots of mistakes. So let's check this one now and see if we go back, do second entry, and then go back and change it to a minus. Whoops, went back too far. Okay, now let's see what we get. Okay, so we get the 0.258819, which we were supposed to. So it's probably good that I checked it because I made a bunch of mistakes there. And I think I even said when I wrote it down it was supposed to be minus, who knows. Uh, but it was supposed to be a minus there, and then 2 times 2 is 4. But I wanted you to see, what I was wanting you to see was that your answers will not look anything alike. So you do get different looking answers, but they have the same values. And so it's important that you learn to do it by each individual method. Okay, let's find another value. Let's say we want to find the cosine of 165. Now, to know what angle we might use, we're going to take 165 and multiply it by 2. So it's half of 330. So this is going to be the same as the cosine of 330 over 2, which is equal to plus or minus the square root of 1 plus the cosine of 330 over 2. Now I like this problem because out here we use the 165 to let us know if we use the plus or minus. 165 is in the second quadrant. In the second quadrant, cosine is negative. So outside, we're going to use the negative. But inside, we're using the cosine of 330. 330 is in the fourth quadrant, and in the fourth quadrant, cosine is positive. So it's going to be a positive. Reference angle is 30. Remember, you go around your reference angle is 30. So that's going to be the square root of 3 over 2. We're in the fourth quadrant, so it's positive, divided by 2. Now we need to get us a common denominator. So for the 1, that's going to be 2 halves. So we have 2 plus the square root of 3 over 2 divided by 2 is the same as times 1 half. And we're going to get 2 plus the square root of 3. And that would be over 4, and the square root of 4 is 2. So it's going to come outside the radical. Okay, let's say we want the tangent of 112.5 degrees. And you can find the tangent of some of your half degrees. If we doubled this, multiplied it by 2, then that's the same as the tangent of 225 over 2. Okay, for tangent, we have some choices. And you can choose whichever one you have. If it ends up that my reference angle is going to be 60, then I like to use the one that has the sine in the denominator, the cosine in the denominator. If my reference angle is going to be 30, I like to use the one that has the sine in the denominator. Uh, in this case, my reference angle is going to be a 45, so it doesn't really matter. But I would then probably use it where I just am going to have one term in the denominator. So I would use the one with the sine. So that's 1 minus the cosine of 225 over the sine of 225. It's just a little bit easier with just the one number in the denominator than having the difference. We didn't have to worry about the plus or minus because that was taken care of when we got this formula. So what we have is 1 minus. Our reference angle, as I said, is 45. And the cosine of 45 is the square root of 2 over 2. But we're in the third quadrant, so it's negative. Over the sine would be square root of 2 over 2. We're in the third quadrant, so it's negative. So again, we get us a common denominator up here, which would be 2 halves. So we're going to have 2 plus the square root of 2 over 2. divided by negative square root of 2 over 2. So these 2's will cancel. We'll have 2 plus the square root of 2 over negative square root of 2. Now we're going to rationalize, so we'll multiply both the numerator and denominator by a negative square root of 2. I did that just so that my denominator would be positive. So that will be, here we've got to consider this is in parentheses, so that's going to be a negative 2 square roots of 2 minus square root of 2 times the square root of 2 is 2 over a positive 2. And when I divide both of these by 2, I'm going to use my commutative property, so I get negative 1 minus the square root of 2. So negative 2 divided by 2 is negative 1. Negative 2 square roots of 2 divided by 2 would be negative square root of 2. And again, you could check that by evaluating this and then finding out what the tangent of 1/12 and a half is. Okay, so you can find values for specific angles. And then the last thing we want to look at is just proving some of our identities using our different formulas. And in some of these, we may also use our double angle formulas or our fundamental identities. But we'll look at several different ones. Let's start out with this one. The sine squared of theta over 2 is equal to the cosecant of theta minus the cotangent of theta over 2 cosecant theta. Now, as we work with this, I would probably consider this side a little bit more complicated. It kind of is up to you as to which one you think is more complicated. But think about it this way. If we took our half angle and we squared it, all we're going to do is remove the radical. So that means we have an idea of what this looks like. When we remove that radical for the sine of half of an angle, we have 1 minus cosine theta over 2. So that we have an idea of what this looks like. We're not sure what this looks like. So I'm going to take all of these and write them in terms of sine and cosine. So we would have 1 over sine minus cotangent would be cosine over sine. And this would be 2 over sine theta. 2 times 1 over sine, so that would be 2 over sine. Well, all of our denominators are going to cancel. So we end up with 1 minus cosine theta over 2, which is what we want it to look like. But we can't just say that that's the sine squared of theta over 2. Remember, in a proof, we've got to go through and make it look exactly like that. So the way we can do that is we can say, well, this is the square root of 1 minus cosine theta over 2 squared. If you take the square root of something and square it, you get what was underneath the radical. And now what's inside our parentheses is the sine of theta over 2. And we want that squared, which we would write as sine squared theta over 2. So that gives us a little proof of how we would prove an identity. Let's look at a couple more. Let's say we want the tangent of beta over 2 and show that that's equal to the cosecant of beta minus the cotangent of beta. Well, again, I would work with this side. Cosecant is 1 over sine. Cotangent is cosine over sine. We have us a common denominator, so that's 1 minus cosine beta over sine beta, which is the tangent of beta over 2. That was one of our formulas that we had. And a nice one to do would be tangent of x over 2 plus the cotangent of x over 2, and show that's equal to 2 cosecant x. Now in this case, I would work with the left side. And for tangent, remember we have three different identities, one with a radical and then two without a radical. And most of the time we dealt with the one where we had the sign in the denominator. So we've got 1 minus cosine x over sine x. Now when I get to my cotangent here, I would not use the reciprocal of this one, because we know that when we add fractions, we need a common denominator. Well, the other one that we had was the sine x over 1 plus cosine x. So use the reciprocal of it. And then we've got us a common denominator. And it makes it fairly easy to do. So we have 1 minus cosine x plus 1 plus cosine x over sine x. Well, the minus cosine x and the plus cosine x subtract out. We have 2 over sine, which we know is the same as 2 times 1 over sine, which would be cosecant x. So if you've got one where you've got a tangent and a cotangent, then use the different identities that we have so that when you add them or subtract them, you already have a common denominator. And let's look at one more. Say we want the cosine to the fourth theta. We want that to be equal to 1/4 plus the cosine of 2 theta over 2 plus the cosine squared 2 theta over 4. Now, we might be able to go through and work with this by saying, you know, that's the cosine of 2 theta 2 times or something along that line, but I'm not sure how we would work with this side to make it look like this side. So we're going to work with the right-hand side. And the first thing I'm going to do is deal with the common denominator, which is going to be 4. So we have 1/4. This one I'd have to multiply by 2, so that's going to be 2. Now, in another section, we dealt with our double angle identities. And if you remember, for cosine of twice an angle, we actually had 3 identities. Cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. Well, since I want a cosine in my answer, I'm going to use the 2 cosine squared theta minus 1 over 4. I multiplied both my numerator and denominator by 2. And then I'm going to use the same one over here. 2 cosine squared theta minus 1 squared over 4. Okay, if I multiply these out, and it's all going to be on over 4, I'm going to have 1. Using my distributive property, I have 4 cosine squared theta minus 2. Now here, if I wrote this down twice and had 2 cosine squared minus 1 times 2 cosine squared minus 1, and use my distributive property, what I would get would be 4 cosine squared, cosine to the 4th theta minus 4 cosine squared theta plus 1. And if you're in doubt on that, then go off to the side and do your multiplication of, well, let's just go down here and do it. 2 cosine squared theta minus 1 times 2 cosine squared theta minus 1. Well, 2 cosine squared times 2 cosine squared would be 4 cosine to the 4th theta minus 2 cosine squared theta minus 2 cosine squared theta plus 1. And so we would end up with 4 cosine to the fourth theta minus 4 cosine squared plus 1. Okay, now if we combine our like terms, we have a 1 minus 2 would be a negative 1 plus 1 would be 0. So those subtract out. We have a 4 cosine squared and a minus 4 cosine squared. So we're left with 4 cosine to the fourth theta over 4. My 4's divide out, and I have cosine to the fourth theta, which is what I was trying to find. So I wanted to show you this one because you may need to go back and look at your squared functions also and use them. You may need to use your fundamental identities, but it's just a matter of usually expanding one of the sides. So what we should be able to do then is, given a function, you should be able to find any of your half angles of that function. Now remember, you're going to have to deal with the sign outside, and that deals where the quadrant that half your angle is going to be in. But inside, you're going to have a different angle, and it's going to be in a different quadrant. So make sure you watch your signs there. We looked at finding values for uh, specific angles, where we did half of our angle. And then also we looked at verifying identities.